Hello, so for our math project we're going to explain basic rules of integration. To integrate, there's just one basic formula, which is x to any power. You'll add the number 1 and you'll put it over its same exponent, which for example 6, we're going to add 1 in the top, so it's going to be x to the 7th power, and we're going to divide the whole thing by 7, which is the exponent is going to represent by the variable n, which is n plus 1, and you do x to the n plus 1 power divided by the whole exponent.
Don't forget to always add the c at the end. It's really important. Also, this is a proper notation for integration. F of x dx. You always have to add it at the beginning. An easy example can be 5x squared dx. In this case, what you do is f of x dx, you leave the 5, then the x, 2 plus 1, 3 over 3. This plus e. This is your integration of this basic formula. Okay, so another thing you need to know about integrate is that the equation always has dx at the end and s at the beginning. Okay, we're gonna begin. In this example, you can't integrate normally because it's a more complex equation. In this case, you need to integrate by substitution. What you need to do is at first, these are the steps. Number 1, check powers of the variables, difference of 1 unit or trigonometric functions. So as you can see, we have 2 trigonometric functions, so step 1, done. Step 2, define u, which is the most complex and the highest part of the equation. We're gonna change it to make it easier to look. We're just gonna rewrite the equation by making these 3 a parenthesis, which is basic algebra. 2x over 3. As you can see, this is the most complex part, so this would be my... Now I'm gonna find the derivative of sine. If you remember from last partial, sine u equals derivative u over
cosine u.
It's gonna be the derivative of 2x, which is 2
Cosine
of 2x over dx. Step 4 is solving for x. So we're gonna do it algebraically. We're gonna pass this one down, du over 2
cosine
2x equals dx. Now you're ready to substitute.
For step 5, you're going to substitute u and dx in the function. So I have my u here, my du here, and my dx, which is the one I'm going to replace in the formula. So I'm going to rewrite the formula with the replacement of the formula. So we write the other thing just as it is, 2x, and we're going to replace this by the u, just by the variable u and to the 3rd power. And the dx, we're going to replace it by the derivation we did back in the day, which is du over 2 cosine of 2x. So now, after we plugged in our variables we're going to simplify, which is step 6. We're going to apply basic algebra. So the cosines cancel, and the 2 cancels as well with the 16. So we got 8 times u to the 3rd power, and the du, you can just ignore it since it got canceled as well. Okay, so now we're going to follow step 7, which is integrate. We got 8x and times u to the 3rd power, and we're going to follow the rules of integration, which is x to the n plus 1 over n plus 1 plus c, which is the most important part. So we're going to start integrating 8 times u to the third power plus 1 over to the third power plus 1, which is the same as the exponent. So we got 8 times u to the fourth power over 4. So as basic rules of algebra, we cancel the 4 and we got 2u to the fourth power. So as we left off, we got 2u to the fourth power, and the last step is turning back to the x terms. So 2 times ru, which is sine of 2x to the fourth power, the whole thing. But remember, we got to add f of x dx equals this whole thing plus c, and that's how you box the answer.
In the part A, we need to find the change in the period of the pendulum if the original length is 4. So the formula they give us is t equals 2 pi times the square root of L divided by G. We know that the G is gravity and gravity is 9.81. So in the problem, they told us that it increments by 0.5%. So we know that 0.5% is 0.5%. So this number, we're going to divide it by 100. Divide it by 100 and it gives us 0.005. So now, this number, we're going to multiply it by the feet, that is 4 feet. So 4 times 0.005, it's equal to 0.02. So this number will be my increment. So now, if I add this to the 4, I will have my second x, and the x1 will be 4. So now we're going to use the formula of delta y to plug in the x1 and x2 to find the answer, because they are asking for the change. So first we're going to do, so delta y is equal to the formula that is 2 pi times the x2, so we're going to put 4.02 divided by 9.81 minus 2 pi square root of 4 over 9.81. So if you plug in this and this one into your calculator, you will get that delta y is 0.01, and you box your answer.
We're going to find the percent of change from the delta y, the answer that we just got. So the difference was 0.01, and we're gonna put it over the original x, which is 4, and we're gonna make it a percent, so we're gonna equal it to 100. So 0.1 times 100 is 1 divided by 4, it's gonna be 0.25. So the percent of change is 0.25%.
In the part C, we're asked to find the approximate percent change in the period. So the formula for approximation is dy equals f prime of x dx. So we know that we have to find the dx, and this is the formula. So like in the problem before, the x2 was 4.02 and x1 was 4. So we get 0.02. Now we're going to derive the original formula that they gave us. So the formula was t 2 pi times the square root of L divided by gravity, that was 9.81. So we're going to derive. First of all, we're going to separate this both with the square root. So 2 pi over times square root of L and square root of 9.81. Now we're going to pass the 9.81, the square root of 9.81 divided by 2 pi. It will be 2 pi over the square root of 9.81 times the square root of L. If you divide this in the calculator, you will have 2.006, and this you can have it like with the exponent 1/2. Now we're going to derive the function. So we're going to pass this as chain rule. We're going to pass the 1/2 multiplying with the 2.006. So we're going to have 2.006 times 1/2, then the L, and remember that we have to multiply 1 here, so it will give us negative 1/2. So if we multiply this, we will have 1.003, and this will come down as the square root of L, because you cannot have negatives exponents on the top, so you have to pass it to the bottom. So we know that this function is going to be our derivative. So now, as the formula says, for the dy of approximation, we need to multiply this by the dx, and we know that the dx is 0.02. So we know that the length given in the problem is 1.003, and the L is 4. And we have to multiply it by the dx, that is 0.02. So we know that the dy will be 0.01003. So if you plug this in the calculator, you will get this. And this is the answer.
So in part D, we need to find the approximate error this pendulum clock has in 1 day. So we're gonna use the result in part C, which is dy equals 0.10103. So we know that this is equal to the error per second, and we know that in a day there are 60 seconds in a minute plus 60 minutes in an hour plus 24 hours in a day. So all these, we're gonna multiply it by the error, which is this one. So we're gonna multiply it by 0.01003. Whichever the result is gonna be our final answer. So you plug it in the calculator. So the approximate error is 856.592.